Hello, so I've been asked about factor theorem and I've got these two questions here. This first question says use factor theorem and division to factorise completely. So using the factor theorem to begin with, they've not given us a clue as to what we're aiming at, so we just try a few things. We could try f of 1, and that's going to be 2 minus 7 minus 17 plus 10. That doesn't equal 0, so that's not a factor. We could try f of minus 1. That will give us minus 2 minus 7 plus 17 plus 10. Still doesn't equal 0. Let's try 2. You only want to be trying factors of 10. Now, of course, you could end up with fractions because you could end up with something like 2x plus 1 or something like that, in which case the number we would be trying is minus a half. So yes, that could be there, but the likelihood that, in fact, is it possible for all of them to be fractions? I don't think so. So if one of them is a whole number, then that has to be a factor of that number. Maybe it doesn't always. If you had a fraction and another fraction, and then like a bigger number, I guess that would be true. But it's almost certainly not going to happen in an exam that they're all horrible numbers. One of them is going to be. So, but my point is, there's no point trying 3 or 7 because they don't go into 10. So we'll try 2 next. If 2 doesn't work, we'll try 5, and then we'll try 10, and then maybe we'll try the fractions. Anyway, let's try 2. So we're going to get 8, we're going to get 16, we're going to get 4 lots of 7, that's 28. We're going to get minus 34, and we're going to get 10. Which makes that a lot harder to check, but it's going to give us 26, so that's not going to work. So we'll try f of minus 2, and we're going to get minus 16. We're still going to get minus 28. We're going to get positive 34 and positive 10. This looks more promising. 44, 30, 44. So yes, that equals 0, and we have found it. So what we now know is we know that this is going to be bracket x plus 2, because it's the opposite sign, and then some quadratic. Now it says to use division. Now if it says to use division, we really should use division, because if you don't do the method they want, then they are not going to give you the full marks for it. You might get a method mark or 2 if it's worth lots of marks, but you're not going to get full marks if you don't do what you're told to do. So we should divide this. So we would put 2x cubed minus 7x squared minus 17x plus 10, and we divide and we get 2x squared. We times it back, 2x cubed plus 4x squared. We're going to subtract, so we're going to end up with minus 11x squared minus 17x. We're going to divide and get minus 11x, times it back, minus 11x squared, and minus 22x. We're going to subtract, which is going to give us, let's think, 3. It's going to give us 5x plus 10. I'm going to divide that by x. We're going to get plus 5, times that back, we're going to get 5x plus 10, which is nothing. And then we've got to factorize this as well, which we should be able to do just as a normal quadratic. So it's going to be a 5 and a 1. We've got to make 10 with the 2x and x, and that's going to give us 11x. Wants to be minus, so make them both minus, and we've done it. It told us to, so we did it. It would have been a lot quicker to do that by inspection instead of having to do all of this. Now, I'm not saying you can't divide quickly, I'm not saying you can't divide well, but there was a lot of calculations there, taking off the power, timesing it back, subtracting, not getting the signs wrong. There's a lot of places where you can make mistakes there. So if they don't tell you you have to divide, then I would strongly recommend that you don't divide, and that you do inspection, which I think we're allowed to do for the second one, which we'll have a look at now. So this one says use the factor theorem to show, and look, they've given us the amount as well. So we can try g of minus 3, and we can get, oh, what's that going to be? Minus 27 times 4. That's a bit rude, isn't it? 27, that's going to be minus 80, and minus 28, so minus 108. And 9 minus 72, and plus 105, and plus 75. And so we've got 100, we've got 70, we've got 2 and 8 is 10, 170, 5 and 5 is 10, so yes, that equals 0. So that is shown. Hence show that it can be written in the form where a and b are constants to be found. This is where we're going to do our inspection. Now this isn't quite right because this is a bracket squared, but what we'll do is we'll get a quadratic and then we'll show that that happens to turn into a repeated bracket. So if we say, well, we know it's going to be x plus 3, and then because this is x squared and x and a linear, and we know it has to turn into this, there's only one way to get the 75, and that's this number times this number. There's no other way to get that, because anything else would have an x in it. So we know that it's got to be 75 from 3, so it's got to be 25. And that's plus, so it's a plus 25. And also, there's only one way to get the 4x cubed, which is the x term times the x squared term. There's no other way to do it. Otherwise, you wouldn't have enough x's to make the x cubed. So it has to be 4x squared. So the only thing we don't know is the linear term, and we can use these two in the middle to do that. Oh, include the minus. One to work it out and one to check it. So we want minus 8x squared. Well, we'll make that from 3 times 4x squared, that's 12x squared. And we'd also have it the x times the number, and we want to be left with minus 8. We've got positive 12, I want to get to minus 8. So I think we need minus 20x, if I've worked that out right. So if we have 12 and we take away 20, we'll be left with minus 8. I think so. We'll check it with the 35x. There's only one way to make 35x, and that, well, sorry, two calculations to make it. So that's the 3 and the minus 20, so that's minus 60x. And then we have the x times the number plus 25x, which does indeed make minus 35x. So we've got that. And then we need to just turn this into a bracket squared, and you can see, well, that's 4 is going to become 2x, and that's going to become 5. And would you look, 2 times 5 is 10, and double it is 20, so we just need a minus sign, and we get that. So obviously you'd write that out again with the first bracket, and then that written properly with a as 2 and b as 5. The key thing is that this inspection has something like 4 calculations in it, compared to that division which had cajillions in. That to the extent that even if I was doing a division, if I had to do a division question, and I didn't have a calculator, I would probably do it by inspection first to know what I'm aiming for, and that way when I'm going through and I can check as I'm going through that I'm getting the right terms coming out. And if I get something that I'm not expecting, then I'd think, oh, and I've probably done a minus. Better than doing the whole thing and it not working and then not knowing where the mistake is, at least you know where the mistake is. And if I've got a calculator, well, I'm just going to shove that in and get it to tell me the answer, mainly because when it says use the factor theorem, it'll just tell me what the solutions are. It will tell me this on the calculator. Why don't you start by trying, let's just randomly pick -2 as a possibility, or 5, okay? Or, I mean, you could try a half, but a bit harder to work out. But at least saves you that time. I had to check 4 different numbers before I found one that worked. Just shove it in your calculator to get what the value is, and then, they're not going to know that you didn't just randomly pick the right guess. So use it. You're allowed to. You've got the calculator, so use it to save yourself that time. So in summary, factor theorem, great. Inspection, easier and safer. And definitely check all your answers on the calculator as well. And only do division if you have to, because it tells you to. Hope that's helpful. If not, tell me all about it in the comments. Say what you want to explain more, or if you've got any other questions, do send them in the usual way. Otherwise, ta-ra for now.